A few years ago, I was working with my then kindergartner on some math when my older daughter, who was in 8th grade, happened to walk by and took a look at what we were doing, and she made a comment something on the order of, "Oh boy, those were the days. That was when math was easy. You should see the stuff I'm working with now." I think even from most adults' perspectives, when we look at kindergarten math, we immediately think that it is extremely low level and easy. It's important for us to remind ourselves that for a kindergarten child, a lot of the concepts they're being introduced to are actually quite abstract, and to give it that credit. If we jump into the abstract, formal knowledge of math too quickly, then we lose an opportunity, and that is an opportunity to connect with the knowledge that children already have and that they bring with them into the kindergarten classroom. Isn't it amazing to think of the cognitive growth that children experience in just that one school year of kindergarten? At the beginning of the year, if all is ideal, the entering kindergartner will be able to meaningfully count out exactly 10 objects with one-to-one correspondence and recognize the value of the entire set as 10. Clearly, that doesn't happen, but wouldn't that be a gift if all of our learners came to us with that? But even if they come to us with that knowledge, which is great, by the end of kindergarten, they're expected to have extended this quite a bit. They should be able to look at symbolic expressions like 3 plus 7 and understand it. Now, this understanding goes way beyond knowing that the solution is 10. They should understand the quantity of 3 and the quantity of 7. They should know what one more and one less is for each of those quantities. They should know the symbol that's shown here means that the two sets are being joined. They should be able to make up a story to go with the expression. Their understanding has to be rock solid because in less than a year from the time they leave your class, they will be expected to use this fact to derive new facts. For example, they will be expected to be able to construct in their mind that if 3 plus 7 is 10, that 3 plus 6 must be 9. Or that if 3 plus 7 is 10, that 4 plus 7 must be 11. And that's in less than a year. They not only need to be able to do it, but they need to be able to explain why that must be true. When you think about it, there is a tremendous leap towards more abstract understanding of numbers during kindergarten. Children do not come in with a blank slate, however. Research shows that children actually have quite a lot of informal knowledge, and they sometimes surprise us with their knowledge. Although typically this only happens if the child perceives a way to connect that rich reservoir of background knowledge with the tasks that are being posed at school. If the task is too abstract, it will appear to you as if they do not have any background knowledge because they don't know how to bring that, access that background knowledge for this given task. So we really need a way of figuring out how to use children's knowledge as a starting point, because that is a rich resource for us to access. Use it as a starting point and then shift it incrementally towards greater levels of abstraction without losing children's capacity to make sense of the mathematics that they're experiencing. We can do this by being very intentional in our instructional sequencing and setting up learning experiences that follow a progression. And that progression should always start with children's where they're making sense. So in kindergarten, we'll start with children's everyday experiences and their concrete representations, and then support them in seeing how those very same representations that they've already made sense of translate into slightly more abstract forms so that the child is always approaching the abstract from a mental place in which they've already made sense of the concept. In this lesson, we're going to examine what this progression might look like for a particular lesson sequence, and then make some suggestions for how it might be generalized as a general approach to instructional sequencing. For our example that we're going to look at, we're going to focus on an introduction of subtraction. Subtraction has actually 3 different interpretations, and one of them is hard. It's the compare interpretation. That one is designated for 1st grade. In kindergarten, they'll be looking at 2 different kinds of interpretations. One is take away, which is the easiest of the interpretations for children to understand, and the other one is a part whole. In this case, the introductory lesson starts out with the one that's most intuitive for children, which is the takeaway interpretation. So we're going to understand subtraction as a decrease in set size. We want children to be able, by the end of our experience, to quantify a starting set, be able to quantify a change, and be able to quantify the resulting set for an actual situation which undergoes a decrease in size. And we want the children to be able to represent this situation with concrete materials. So this is actually an example from a lesson in early bird kindergarten mathematics. And this is the curriculum my daughter was in, so her textbooks are handy. But this is the first thing that happens on the very first page for subtraction. And children are encouraged to study this picture and think about what they see and to predict what they think will happen next. There are some things to quantify here. You see the boy with the pin, so they may have a clue that something will happen with the balloons there, but there are a certain number of balloons. There's also some birds on a branch. This is actually a piece of a picture. There's another portion that you don't see. But in this picture, we're able to access children's background knowledge. They have experience of balloons. They probably have experience of balloons popping. I would expect them to probably know what happens if you poke it with a pen. And it gives them an opportunity to bring up some background knowledge for a situation that we're going to use in a sort of kindergarten story problem setting. Then we'll have them turn the page and they'll be able to notice what's happened here and talk about that. They'll be able to study it. They'll be able to think about what happened. You see that the birds have flown off and that 2 of the balloons are popped, so children can articulate that. This would be a good time also for you to elicit from them some of their observations about the quantities of balloons. How many balloons were there? How many balloons does she still have? You know, why is she crying? How many balloons popped? That type of a thing. At this point, we're going to give the children another concrete experience to make this even clearer, and we can have balloons in the classroom, and we can actually model this whole problem for ourselves. And so this gives children an opportunity to act it out in a concrete fashion, and gives them another anchor experience as they move into some of the activities that they're going to do. Then there's a series of images similar to the one you see at the top, where they can actually use the clue, one burst, to illustrate that one burst by putting a cross through it or an X through it, and then figuring out how many are left. The child gets a little card, and they're supposed to cover up the ones that are popped and figure out how many are left. And then once they've covered up the ones that are popped, they can put an X through them. This is a concrete to pictorial. The children were actually enacting a situation, and now they've moved to some pictorial images of that situation. And I could choose to reinforce this further by giving the students these part-whole cards, which is what you see on the bottom. And at the top of the card, it shows that my total amount is 5, but that some are popped and some are not popped. And so the children can actually move the counters to represent the scenarios which are in the problem. So now we have the visual image of the picture. We actually have the acting out. We have the pictorial image of these balloons now along a bar, and then the part-whole model. So you see several different representations where we're shifting them from a situation, very contextual, to gradually decontextualizing and thinking about the quantities, but still in a way that's very appropriate for kindergarten. This particular image comes from 5 lessons in, and at this point there have been a number of opportunities for the children to act out situations, both through little dramas and also with counters to get them to start and use counters. And they've already had experience at this point with the number bond, so I can try to represent the relationships between the values in a number bond. That would be fairly abstract for kindergarten. I might begin by actually putting the numbers of cubes. So we started out with, like for example, in the previous scenario, I could put 5 cubes in all together, and then I could move 2 cubes that were popped and 3 cubes that were unpopped balloons. And so I can use some number bonds too as another example of a representation. We'll be learning more about those representations later this week. And then about 5 lessons in, they've already been exposed to the second interpretation of subtraction, which is the part-whole one. And now we finally get into equations. So children have quite a bit of experience before they get to equations. And when they do get to equations, they will be asked by the teacher, what do you think the 6 represents? Look at the picture. What do you think the 6 means? 6 what? And so they talk through the meaning of this, but notice that the visual image has the whole story embedded in it. So they can use these visual images very clearly to recreate a story and then to connect that story that already makes sense to them based on all the work they've done to this more symbolic language of mathematics. So there you see an example of a concrete pictorial to abstract progression where we always start with what they know, make sure that's really solid, stretch it a little bit, and then the next day stretch it a little bit further, and make sure they have an opportunity to see multiple representations at two different levels of abstraction, starting with the one that's familiar and extending it a little bit onward. So that's called the CPA approach, or Concrete Pictorial Abstract, and it is a developmental pathway. I should point out, though, that the word developmental doesn't mean we do concrete for a week and then we do pictorial for a week and then we do abstract for a week. Actually, this pathway is present even within lessons because you start your lesson out more concrete and you're looking at how to incrementally stretch children to another layer of abstraction. So concrete for kindergarten is going to involve direct modeling, acting things out, making sense of familiar situations. We saw all of those already in our example. Pictorial representational begins to abstract some of the elements. So we're moving towards image-based and towards more iconic representations rather than the actual real deal. And then abstract is where we start to work for kindergarten. That's going to involve numerals and the numerals in a number bond, and eventually the equations would represent kind of the abstract end for kindergarten. Some guidance here. Lessons really need to be grounded in this concept. So when you think about how to sequence your lessons, think about what can we do to begin with. It will be really concrete where the meaning of what we're doing is going to be crystal clear to all of my learners because we've experienced it together. And then how can I stretch that incrementally towards a level of abstraction that's appropriate for these learners and for this concept. However, each lesson should consciously incorporate at least two representations at varying levels of abstraction, so children get accustomed to always taking their more informal knowledge and stretching it into a more formal and more abstract, even if it's not all the way to symbolic, a more abstract version of it than what they originally had. Now, in order for this concrete pictorial to abstract progression to work well with your learners, there is one thing that has to be considered, and that is whether the representations you're using are analogous. This is not just meaning, oh, we'll do a little concrete activity at the beginning of class and then we'll be done with that and we'll shift to this pictorial task. There actually has to be an obvious connection in the learner's mind between what we did with concrete and what we did with pictorial. And if the two tasks seem radically different in the mind of the learner, they won't ever think that that concrete relates to the pictorial. So you lose all the value of coming in from that point of meaning because they're not bringing that meaning to the new task. So think about how you can stretch the thing that you already did and make that thing a little more abstract, but still similar enough that the students can connect the two. Now, some people think that the whole purpose of the CPA is to get rid of the concrete and pictorial as quickly as possible so that we can be at abstract. That's not exactly the case. We obviously do want children to be able to cope well at the abstract level and to be able to have meaning for it. But there's a great deal of deepening of children's understanding by actually having to make connections between representations. And so the connections that they build between the concrete, the pictorial, and the abstract representations is really advantageous. In fact, I think when children make a real leap forward, in my experience, most often that mathematical aha is because they made connections between representations rather than of just one representation. So our purpose is actually to help them build connections between these different representations so that they build a stronger conceptual understanding, a deeper mathematical base of knowledge. Also, we want to be able to extend their thinking from where they are, constantly stretching them because that's how they develop their intellect. And so we want them to regularly experience instruction that brings them along for the ride, not having them lost, but which stretches them intellectually. If you want to know a little bit more about the concrete to pictorial abstract progression, you might read some of Bruner. This is just really a start-off website here, but Bruner's theory is kind of the basic learning theory upon which it's based, although he used different terminology. He used inactive,